GRE is a test required for admission to many U.S. graduate schools. Students' scores on the quantitative portion follow a normal distribution with mean 150 and standard deviation 8.8. So we've seen an example like this before. We're going to look at it a different way now. So suppose that n equals 16 randomly selected students take the GRE on the same day. What is the probability that one randomly selected student scores above 147 on the quantitative portion of the GRE? So this is nothing out of the ordinary, just like what we did in the chapter with the normal distribution. So we have here that our mean is 150 and our standard deviation is 8.8, and that these scores follow a normal distribution. So we are looking for the probability that x is greater than 147. So that's what we're trying to find here. So I'm just going to plug everything into StatCrunch. So you're going to go to Stat, and then Calculators, and then you'll find the normal calculator. So I already have this pulled up here. So our mean here is 150, and our standard deviation is 8.8. Look for the probability that x is, and we're going to have to type in greater than or equal to, so remember it's an equivalent statement. Since we're looking at a continuous variable, the probability there of it getting that exact score is 0. So this is 147, and we're going to hit compute. So our probability here is approximately 0.6334. So that's our probability there. So I'm going to rewrite this. So 0.6334 is the probability that a randomly selected student scores above 147. So now let's look at the next question. It says describe the sampling distribution of the sample mean. So new phrase here. Sampling distribution of the sample mean. Right? For the quantitative GRE scores for the 16 students. So we're talking about a sampling distribution here. So there's a couple things we have to keep in mind. So when we're talking about describing the sampling distribution, we want to talk about the shape of the sampling distribution, the spread, and the center. So we talked about that previously, and we're going to talk about that again here. So first, let's talk about the center. So the center is our mean. So the center is going to be mu sub x bar. So in chapter 6, with the binomial distribution, we're talking about random variable x, we had mu sub x, but this is mu sub x bar, which indicates that we're working with the sampling distribution of the sample mean. So remember, sample mean, we use x bar. So this is equal to just the mean of our distribution, which was 150. So that's our center. Right? And then our spread is our standard deviation. So sigma sub x bar, so sigma is our population standard deviation. So this is sigma divided by the square root of n. So in this case, 8.8 is our sigma, divided by the square root of n, and the square root of n here, our n is the 16. So this is 8.8 divided by, and just to remind you guys how to use square roots in the calculator, you're going to hit second, and then you'll see that x squared has blue above it with a little square root sign, so I'm going to hit second to activate that, and then hit my x squared button, and then I'll type in 16, close the parentheses, say I just want to take the square root of 16, and enter, and I get 4. So this will give me 2.2. 8.8 divided by 4 gives us 2.2. So that is the spread of our distribution. So notice our sampling distribution has a smaller standard deviation. So the spread, right, is not as right? So if we're talking about the spread, right? The smaller the standard deviation, the less dispersed our data, right? And the last thing we're going to talk about, whether it's normal or skewed or whatever. So our population distribution, right, was, right, let's go back up, normal. So this means that our sampling distribution of x bar is also approximately normal. Right? So if it didn't tell us that, then we would look and make sure our sample size is large enough. In this case, it wouldn't be because it's 16. We want our sample size to be greater than or equal to 30, and that's just a rule of thumb. So what can we say about our sampling distribution? So the full way that we would write this out here, we would say a sampling distribution of the sample mean expand this for a second, do it smaller. A little bit too small there. Sampling distribution of the sample mean is approximately normal with mean 150 and standard deviation 2.2. So that's what we would say when we talk about describing the sampling distribution. So now let's go on and look at the next part here. We have, what is the probability that a random sample of 16 students has a mean score on the quantitative portion of the GRE that is less than 147? So if we scroll back up to part A, you'll notice that it doesn't say mean, and we're not talking about a sample size. So this is what indicates to us that we're working with a sampling distribution. So key words here, a random sample of 16, mean score. And so it tells us we're working with a sampling distribution. So our mean is the mean that we just found of 150, and our standard deviation is that new standard deviation we just found of 2.2. So we're looking for the probability that a sample mean here, right, that we have a mean score from a random sample, so a sample mean is less than 147. So notice before we were writing z's and x's, now we have x bar because we're looking at a mean score. And that's what we're trying to calculate. So we're going to come over to StatCrunch, and our mean is still the same, but our standard deviation changes. So notice this looks similar to the previous chapter, just our standard deviation has changed. And this is less than or equal to, and we have our compute here. So we have 0.0863, right? And then part D here. So again, we're looking at a random sample of 16 and a mean score. And then we're talking about greater than 147. Right? So this looks almost identical to part A. We're talking about above 147 and greater than. Right? So again, our mean of the sampling distribution, the standard deviation of the sampling distribution, or what we also call the standard error. And then we're looking for the probability that x bar is greater than 147. So I'm going to change this to greater than and compute. And we'll notice here, if we compare this, oops, try this again here. Notice if we compare this to our answer from part A, we get a different answer, and that's because we're working with a different standard deviation, right? So it's less spread out, right? So we're going to get a different answer there.